Okay, so we're going to start off with this bell work here, and all it's asking you to do is to figure out if the order pair, so the coordinates right here, so we know coordinates are x and y values, and it wants to know, based off these two equations, is this coordinate a solution? Meaning, is it true to the equation? So in other words, there are two equations, and what I'm going to do is plug in my x value and my y value and see if I do get the number that's on the right-hand side. So I'm going to plug in 5, I'm going to plug in 1, and when I add them, I do get 6, so that one works. If I plug into the second equation, 5 minus 1 does give me 4, so this pair is true, or is a solution. This one here is a 5 and a 2, so I'm going to plug this one in. That's going to be 2 times 5, because that's my x, minus my y, which is a 2. So if I were to work this out, I would have 10 minus 2, which does give me 8. So the first equation works. Now I'm going to plug this into the x down here and the 2 for the y. So this is 3 times 5 plus 2 times 2. If you work this out, this is 15 plus 4, which is 19. That's a 20, and I did not get 20. I got 19, so this did not work. So because it failed for one of the equation, you can't say that this is a true solution for both of the equation, even though it worked out for the first one. So this is false. And that's it. So that's how you can test if a order pair or coordinate is a solution for both equations. You got to plug it in. All right, let's get into today's lesson, which is about solving systems of equations. Systems of equation means I'm going to give you 2 equations or multiple equations, but in this case, just 2 equations, and you have to figure out what x or y value works for both equations. And so this is called solving for systems of equation, and there are 3 ways you can solve. So to solve a system, there is 1, graphing, and 2, there is something called substitution, and 3, which we'll learn tomorrow, is elimination. Those are the 3 ways we can solve a system of equation, and I'm going to teach you in this video 2 of the ways. So let's go over definition first. When solving for a systems of equation by graphing, one of the things you want to do first is to solve for y. So when you have 2 equations, you need to make sure the y is by itself, so that way you can easily graph your slope and your y-intercept. So we want it in slope-intercept form so we can graph it easily. And when you graph both equations, what you're looking for is where does the 2 line intersect. So using a graph, you can find a solution for 2 linear equations or 2 lines by seeing where they intersect. All right, so in the next slide, I'm going to try out some practice problems with you from the homework. Okay, so in here I have problem number 4, and I have 2 equations, as you can see, but I need to graph them. So the first thing I'm going to do is get the y by itself. Like this y is almost by itself. I just need to move over this x, and in this case, to move over this first equation here, I'll call this the second equation. To move over the first equation, I have to subtract x to both sides so that can cancel. So this equation would be, let me just write an arrow, y equals 4 minus x. Since I can't combine the 4 and the x, so I'll just carry that over to the right side. So I need to graph this equation, and I also need to graph this one. So I'm going to solve for y first, and I need to start by subtracting the 2x over, so that cancels. So then you'll have, let me carry this over, negative y equals 2 minus 2x. Then I have to divide by a negative 1, or just switch the signs, right? So this would be y equals negative 2 plus 2x, since 2 negatives make a positive sign when you divide. So looking at this, I have to graph this first equation. Notice how my intercept here is at 4, so I'm going to graph the y-intercept at 4. And my slope here is negative 1. So if the slope here is negative 1, it's negative 1 over 1. So So I have to go down 1 over 1 and plot, and then I'm going to draw my line. Now I'm going to add more points here using my slope, just so that I can get as much accuracy as possible. Because I need to make sure I hit my other line as accurately as possible so I can figure out the intersection. So this one's at -2, so it's down here for the y-intercept. And the slope is 2. So this is going to be up 2 over 1. So I'm going to go up 2 over 1, which would be right here. I'm going to go another up 2 over 1, and I hit the pink line. So it looks like my intersection is right here, and that coordinate right there is 2, 2. So this is my intersection. So when x is equal to 2 and when y equals 2, that means that they intersect. And that would be my final answer. So I'm looking for where do the two lines when graphed intersect, and you have to start off by getting the y by itself so you can graph it easily. Alright, so I think I just noticed a mistake here in my key. I'm going to fix this real quick, but this side here should have been a -5, not a -15. I was wondering why that number is so big. -5, not -15. So to start this off, I'm going to just label my equations 1 and 2. And to start this one, I just need to subtract the x over so I can get the y by itself. So if I subtract this x here, I need to subtract it to the other side. So now y is by itself on the right side, and this is -5 minus x. So that's my first equation. My second equation, I need to add 2x over to both sides. And then this would give me y equals 1 plus 2x. And so looking at this, my slope looks like it's 2 over 1. And the top one looks like it's -1 over 1. So let's start graphing. Now, this is at -5 for the y-intercept, so I'm going to go down to here and plot my point. And then I'm going to go down 1 over 1 plot, and I can't really plot anymore. So I'm going to go the opposite direction now, so up 1 over 1, up 1 over 1 to continue my slope. Because remember, we want as many points as possible to keep the accuracy so we can find a clean intersection. Then for the next one here, this is at 1, so I'm going to plot it at 1. And it looks like the slope is 1 over 2, so up 1 over 1. But notice, like, if I were to add more points here, it doesn't help me because it's not hitting the pink line. So I have to go down 2 over to the left, down 2 over to the left, and then bullseye. I did hit that intersection right there, which is -2, -3 is my intersection. Oops, sorry, I can't spell. Intersection. So, to solve for a system of equation, you have to make sure y is solved to be by itself so you can easily graph the y-intercept and the slope and graph your line and then find where the two lines intersect. Alright, let's go into substitution. Okay, so for this problem here, it's solving a linear systems equation by substitution, and what you have to do is choose a variable and then solve for one of the variables. So you're going to take one of the equations and solve for one of the variables, then plug the equation that you solved into the other equation to find the x and y values. So we're going to see how that plays out in our next problem here that I've chosen from the homework. So here I have problem 17, and you can see here there is a 4x plus y equals 6, and then this one is y equals 2x. And so first thing you want to do is make sure that that you have solved for one of the variables. So this one's kind of nice because y is already solved for you. So technically, I can take what y equals and substitute it into the other equations y to figure out what the other variable is. So notice if I were to replace this y with 2x, because that's what y equals, let me do that over here. So I'm going to take the first equation, 4x plus y, but instead of y, I'm going to write in 2x, and then this equals 6. So if I were to look at this equation, notice how this side only has x's now. There's only one variable, which is good because then you can solve it. So looking at this, 4x plus 2x gives me 6x, and then the other side is still 6. So I'll bring that down, and then I have to divide by 6. So x had to have equaled 1 because 6 divided by 6 is 1. All right, got my x value. Now I need my y. Now, I can plug this x into either equation to solve for y, but I think I'm going to choose the second equation, because if I plug in 1 into here, well, y equals 2 times 1 is easier to work out, and I just get 2. Let me write it this way. Get 2, and so now I have my x, and I have my y, and so I know that the intersection is at 1, 2. So this is technically, if you were to graph these two equations, it would hit it at 1, 2. That's what these x and y value mean. They are intersections. All right, let's try out another one. So this one here, 2 equations, and again, the second equation, the y is already solved for you, so you don't have to solve for y, but I still need to solve for my x and y. So what I'm going to do is take what y equals and replace it with the y that's in the other equation. So this is going to be negative x minus 4, and I'm going to put parentheses and plug in my y value, which is the 2x minus 1 in replace of y, and then equals negative 14, and then work this out. Again, there is just x's now on this side, so it makes it possible to solve. So this side here, there's a negative x, so I'm going to just bring that down. There is also a negative 4 here, so I need to distribute that because this is in front of a parenthesis. So if I distribute, this is negative 8x, and then a positive 4 here. So negative 4 times negative 1 gives you a positive 4, and then I just brought down the negative 14. And so from here, I'm going to combine like terms, but like these two are both x's, so that's a negative 1, that's a negative 8. If I combine them, that is a negative 9x. Bring down the 4, bring down the negative 14. I'm going to subtract off the 4 on both sides. And then negative 18 comes down, and a negative 9x comes down. So from here, I can easily just divide by a negative 9 to cancel that out. So x is equal to positive 2. So I got what x equals. Now I need to go find what y equals. So I'm going to make some space here. So I'm going to go back to this equation since y is already solved and plug in my x to find y. So I have y equals 2 times 2, because that's where x would have been. And if I work this out, this would be 4 minus 2. So y has to equal 2. So my coordinate or my intersection here is 2, 2. And that's it. So I hope this video helps you out with figuring out the homework problems that are optional for you guys to try out. All right, until next time, guys. Bye.